All right, for this lesson, we're still going to be working with percents, but we're going to be using inverse operations because we're going to work backwards. So normally we would have to find some sale price or some markup or some discount where we would use multiplication at some point. We multiply our percent by our number. But in this case, you're going to be working backwards. So instead of using multiplication, we're going to be using division. And instead of being given a price, we're going to be asked to find the original price. Normally, like in the last two videos where I broke them up into part 1 and part 2, finding percents, we're working with percents. Normally what we do is we be given a price and then a percent, an original price, and then a percent, and then we would have to multiply. But now you're going to be looking for the original price. So we're going to work backwards when we're looking for an original amount. All right, and I gave you an example. Now we're not going to do this to start off with, but I'm going to show you exactly what I'm talking about as far as looking for an original amount. It says Alicia purchased an item on sale for 10% off for $36. So basically, after they gave her the 10%, she ended up paying $36. So I want to know what was the original price of the item. In other words, before the 10% was applied, what was the original price? And if we're in class, normally I have students do this and they multiply and they get the wrong answer. All right, but we're not going to do the answer right now. Look at the answer. What we're going to do is go to this part right here. So we're going to be going to this part right here, guys. All right, so let's take a look at this. It says, when working backwards through problems, or basically finding an original amount. So when finding an original amount, we use inverse operations. So we don't do what we normally did on the last lesson where we would use multiplication. So using an inverse operation means you do the opposite. On the last lesson, we multiplied. So let's go ahead and look on to the next sentence. It says, normally we multiply a price by a percent to find a markup or a markdown. But in order to find the original price, we have to do the opposite or the inverse, which is instead of multiplying, we have to divide. Okay. Guys, this next part is really important and I put it in bold. So you notice on the last two videos, I either had you, when you're looking for a total price, I either had you add 100 or subtract a number from 100. So this should be fairly simple because we're going to be doing the same thing. So it says, look at this. Do not use the percent given to you. If it is a markup, you're going to add 100 to the percent and use that number. Okay? However, if it is a markdown, I don't want to do that. All right, let me get my highlighter back. If it is a markdown, you want to subtract the percent from 100 and use that number, okay? So we're on all of these, if you're looking for an original amount, you're either going to be adding 100 or subtracting the number from 100% from 100. Now, when you're just when you're just working with percents normally, and you're not looking for an original amount, you don't necessarily have to add 100 or subtract 100. Sometimes you may just be looking for the discount. Or you might just be trying to find the percent of the number. So you would just be using like card 1 and card 2 from the previous lesson or from the previous video, which didn't involve adding 100 or subtracting 100. But in this case, anytime you're looking for an original amount, you're always going to either add 100. Part of the video you're always going to add 100 or subtract the number from 100 when you're looking for an original amount. So just keep that in mind. And instead of multiplying, we're going to divide. And a lot of students will forget that you're working backwards because you're looking for the amount you started off with instead of being given the amount like in the last lesson. So you got to work backwards. All right, so we're going to use this right in here to go back up here and do this. Okay. All right, so it says Alicia again purchased an item on sale for 10% off for $36. So obviously she paid the 10% off and got it for $36. All right, so what we want to do first of all is determine whether I add 100 or whether I subtract 100. Okay, so let's subtract from 100. So let's look at this. 10% off. Well, that's a reduction. You take something off, you reduce it. So what I'm going to do is subtract 10% from 100. So I end up with 90%. Okay. Now the second step, I know some of you think, oh, I multiply. No. We're trying to find the original price now. So we're working backwards. We weren't given the original price. We're looking for it. So if you're working backwards, instead of multiplying, you're going to divide. So you're going to take your $36 and divide it by your decimal. And let me go back and let me change this percent to a decimal. I'm skipping a step. Let's change that percent to a decimal. So we're going to change 90% to a decimal. We're going to drop the percent and move it 2 places to the left, the decimal. If you don't see a decimal, it's at the end. So that's 90 hundredths or 9/10. I'm just going to drop that last zero and write 9/10. Okay, we're not going to multiply our decimal by the number that was in the problem. We're going to take the number and divide it by the decimal. Okay, so if you take 36 and divide it by 9/10, you get $40 was the original amount. And again, the difference between this kind of problem and what we had previously is previously we were given the original amount. Now we're looking for the original amount, so we got to work backwards. All right, so that should be pretty simple. You either add 100 to the number or subtract the number from 100. Change your decimal to a percent, and instead of multiplying, divide. That's all you do. Okay, we're going to keep following those steps. All right, it says after a 6% tax. Well, tax is an add-on, so I'm just going to make a note of that. That's what you add on to something. After a 6% tax, a new pocketbook or purse cost Sarah $27.55. Okay, but that's after the tax. That's what she paid. I want to know what was the original cost of the purse. So I want to know what was it before they put the tax on it. So, tax makes things go up. So obviously before the tax, it was less than $27.55. But let's just walk our way through it because this is an add-on. Tax is an add-on. I'm not going to subtract 6 from 100. I'm going to add it to 100. So I'm looking at 106%. So she paid basically 106%, which is why she ended up paying $27.55. The original amount, or what we call the subtotal, has to be less than that, okay? So what we're going to do now is change 106 to a decimal. We're going to drop the percent, move the decimal, which we don't see. So it's at the end, and you're going to move that decimal from the end 2 places to the left. So we end up with 1 600. Now what you want to do is divide. So you always take your original, your new cost, which is $27.55, and divide it by the decimal. So instead of multiplying by the decimal, divide by the decimal to find the original. So you're going to take 2755 divided by 1 600. You're going to get some long repeating number. It's not even repeating. It just keeps going. All right, so I'm going to go out to the nearest thousandth. And this is what you should see, but you should see some more things, but I only worry about to the nearest thousand. So I'm going to round not to that place value. Let me undo that. I'm going to round to this place value. That 0 tells that 9 to stay the same. So the original cost was $25.99 was the original cost. But of course, with tax, it made it go up to the $27.55. All right, let's look at the next problem. Carter bought a Captain Hook boat on sale for 25% off for $28.50. So after he paid the 25% off, after they took the 25% off, he ended up paying $28.50. I want to know what was the original price. So again, working backwards. All right, so the discounted price was $28.50. In other words, that's what he paid after they took the percent off. That means the original price had to be higher, okay? Because the percent off is a reduction. So they reduced some amount, okay? But it's a reduction. So instead of adding 25% to 100, I'm going to subtract 25% from 100. So that tells me I'm looking at the number, the percent 75. All right. And so I'm going to change that percent to a decimal. I'm going to drop the percent and move the decimal 2 places to the left where you don't see the decimals at the end. And then you're going to do step 3. Instead of multiplying by the decimal, you're going to divide by the decimal. So when you divide 28.50 by 7,500, you get 38. Okay. So basically the original price was $38. Okay. And that's it. That's all you do. So still you either add 100 or subtract 100. Still moving your decimal 2 places to the left to change your percent to a decimal. But instead of multiplying your percent by the number, you're dividing your number by instead of multiplying your decimal and the number, you're dividing the number by the decimal. So again, working backwards. All right, look at 3. It cost Isabel $20.14 for a Barbie doll after a 6% sales tax. So sales tax makes things go up, so it's considered as an add-on. What was the original price? So if you're looking for an original price, you have to decide, do you add 100 or subtract 1 from 100? All right, because it's an add-on, I'm going to add the two. 106, making it 106%. All right, so I'm going to change this. Drop the percent. I'm going to change it to a decimal. Move it over twice to the left. So that's going to put us at 1.06. And then the third step will be to take my number, $20.14, and divide it by the decimal that I just got. Okay, so let's take $20.14 and divide it by 1 600. And we get the original cost was $19 before the tax was added. Okay. And that's it. That's all you do. And we should expect the original price to be lower before tax is added. Because tax again makes things go up. All right. After my 20% teacher discount, a new desk will cost me $68. What was the original price of the desk? So before I actually paid, before they took the 20% off, what was the original cost of the desk, because it wasn't $68. So if your discount is a reduction, that means after they reduced it by some amount, it was $68. So since it's a reduction, I'm going to subtract the 20 from 100, which is 80%. Basically, I'm going to pay for 80% for the desk. All right. So I'm going to take that 80%. I'm going to drop the percent sign and move the decimal 2 places to the left, which puts me at 80 hundredths. Or I can drop this 0 and write 8 tenths. And the third step, instead of multiplying the decimal and the number, I'm going to take that number and divide it, because I'm working backwards to find the original cost. What was it before the discount? So anytime you're looking for the original cost, make sure you're dividing and not multiplying by the decimal, okay? If you're not looking for the original, it's okay to multiply. So the original cost is $85. And as expected, it is higher because it was only $68 once they took the discount. All right, let's look at 5. All right, I did not do multiple percents with you all in the last lesson, simply because we only have 3 weeks left from May the 4th to the May the 22nd. And I didn't have enough time to cover that. So I'm not going to do 5 and 6 with you. We're just going to stop at 4. I'm trying to keep it as simple as possible. But next year, what I'll do is review some of these things, okay, before we actually go into some 8th grade standards. And this will be one of the things I need to go over. But right now, I just need you to stick to the basics and find an original cost or original price, all right? So we'll stop right there.